Okay, what we're going to look at today is one of the most important, most useful concepts in mathematics. It's the Pythagorean Theorem. So we're looking at section 12.6, the Pythagorean Theorem and its converse. And the first thing we need to do is to actually state what Pythagoras' theorem was. And his greatest insight was the discovery that when you have a right triangle of this form, and you have sides A, B, and C, then the relationship between the sides is always thus: a squared plus b squared equals c squared. Okay? And this is true for any right-angled triangle. We have a special name for the longer of the three sides, and that is known as the hypotenuse. The other two sides tend to be referred to as legs. All right, so I think what we're going to do first is we are going to do a specific example of how to use Pythagoras' theorem to solve a problem. Okay, so there's our problem. There's our triangle. We have a triangle with a vertical height, a leg of 6, a horizontal length of 8, and the hypotenuse is unknown. It's c. So we write down Pythagoras' theorem: a squared plus b squared equals c squared, and we just substitute our values into the appropriate places. So a is 6, so 6 squared plus b is 8, 8 squared equals, we don't know what c is, so we'll leave it as a variable, c squared. So we have an equation like this. Now, we've been looking at these kinds of equations recently, so let's try and resolve this. So 6 squared is 36, 8 squared is 64 equals c squared, 36 plus 64, 100 equals c squared. So what we need to do now is to isolate c to work out what it is, and we will need to find the square root of those two items. So the square root of c squared is c, the square root of 100, well, this is quite easy, we should know this one, 10. So c equals 10 of whatever units it is. Okay? Nice, simple problem. So let's look at another example. In this case, we know A and C, and we don't know B, but the relationship is still the same. Remembering that A squared plus B squared equals C squared. Let's put our values in there. A is 5, so 5 squared. B is unknown, so we retain the variable, but plus B squared equals C squared. C is 6 squared. Okay, let's evaluate this and work out what the numbers are. 25 plus b squared equals 36. We need to isolate the variable b. We do this by the inverse operation of subtracting 25. So b squared equals 36 minus 25. b squared equals 11. And we then need to just find the square root of that. So in order to evaluate b squared, or evaluate b, we square root both sides. B equals the square root of 11. And if we want to assign a value to that, we go to our calculator, work out what the square root of 11 is, and it's approximately 3.32 of whatever the units are. Okay? Great. So what I'd like us to do, I'd like us to start off with working on some problems. We're going to be going to page 727, and the questions are going to appear below. They're questions 13 through 24. And there they are. What I'd suggest you do with all of these is, the first thing you do is to actually sketch what you've got. So we'll do question 13 together. Okay? So let's have a look at the the elements. We're going to do question 13, and it says, find the missing length of the right triangle if A and B are the lengths of the legs and C is the hypotenuse. So let's quickly sketch that. We know that it's going to be a right triangle, it states so in the question. We know there's going to be a right angle. We know we've been given C, which is the hypotenuse, which is the longest leg. We have been given one of the others, so that's 3. We're not sure what the third is, and that's going to be B. So putting them into our pattern, remembering that Pythagoras' theorem states A squared plus B squared equals C squared. So in this case, 3 squared plus B squared equals 4 squared. B squared equals 4 squared minus 3 squared. B squared equals 16 minus 9 equals 7. So B equals the square root of 7. And if you want to evaluate that. Okay, so that would be a complete answer for one of these problems. So please could you work through these problems, starting at question 14 and going through until you are comfortable that you have got this. Okay, let's look at another type of question that we might get. Sometimes these are combined with some forms of algebra, so we might have a problem that looks like this. And again, we're looking at Pythagoras, so we know that A squared plus B squared equals C squared. In this case, A is represented by x, so that's x squared. B is x plus 3, and C is 15. Okay. Now, the first thing we need to do is we need to multiply out these brackets here. Now, x plus 3 squared, if you can remember how we did that, we used to, when we were solving these kinds of problems, x plus 3 squared is x plus 3 times x plus 3. Using FOIL, that gives us x squared for the first term, then outside terms, plus 3x, inside terms, plus 3x, and then last terms, plus 9, which gives us x squared plus 6x plus 9. So let's put that into our expanded problem. So we would start with the x squared, then the x squared plus 6x plus 9, and 15 squared is 225. We would need to combine like terms. So here we're combining x squared and x squared. So let's simplify this expression. So 2x squared plus 6x plus 9 equals 225. Let's balance our equation, so we need to subtract 225 from each side. So 2x squared plus 6x minus 216 equals 0, and we need to solve that. Now this is a quadratic equation, and we can solve this using the techniques we've used before. So let's think about that. Everything is divisible by 2, so let's do that. Let's try and simplify it. X squared plus 3x minus 108 equals 0. And so now we need to factorize our equation using the x plus p, x plus q method, remembering in this case that p plus q equals 3, and p times q equals negative 108. Okay, So let's factorise 108. 1 times 108, 2 times 54, 3 times 36, 4 times 27, 6 times 18, we're getting closer, 9 times 12, ooh, I think we're there, okay? Now, don't forget, it's negative 108, so one of these terms is positive and one is negative, so what I think this is going to be, because it's plus 3x in the middle, it's going to be x plus 12, x minus 9. So therefore, x equals negative 12 or 9. Now, if we look at the context of the question, is negative 12 a possible number for this problem? I don't think it is. If you think about it, we've got a value here, x. If that was negative 12, we would be considering a distance of negative 12 meters or something like that. That doesn't mean anything at all. We don't have an understanding of what that could possibly mean. So what we would say is negative 12 is an impossible answer. What we're going to do is we're going to go with x equals 9. So, back to our problem. This would be 9 units, this would be 12 units, and the other side would be 15 units. Okay? So, quite a long, drawn-out problem. I think we'll do another one as an example. So let's try this one. We've got a right triangle, and there it is. So a squared plus b squared equals c squared. In this case, the hypotenuse is x plus 2. So let's fill in our values. So that will be x plus 1 squared plus x squared equals x plus 2 squared. X plus 1 squared will simplify to x squared plus 2x plus 1. Then we add the x squared. X plus 2 squared simplifies to x squared plus 4x plus 4. Okay, let's collect all of the various items together. So I'm going to start with collecting the x squareds. So that would give me x squared. Now, let's collect the x's. Minus 2x. And finally, we'll collect the constants. Okay, x squared minus 2x minus 3 equals 0. Let's factorize this. So this is going to be x plus p, x plus q, where p plus q equals negative 2 and p times q equals negative 3. Let's factorize negative 3. 1 times negative 3, negative 1 times 3. So I think that's has to be that first one there. That's what we're going to have. That's what we're going to use. So that would be x plus 1, x minus 3 equals 0. Therefore, our possible answers are x equals negative 1 or 3. Let's look in the context of the question. We have a distance of x. If x was negative 1, this would be a distance of negative 1 meters, making no sense at all. That's an extraneous solution. However, 3 does work. So this would be 3. 3 plus 1 would be 4. 3 plus 2 would be 5. And so our triangle would have those lengths, 3, 4, and 5. Right. Okay, problems we're going to be looking at are on the same page as before, 727. And they are questions 25 through 30. I'm going to include them below. and there they are. Okay? So, do as many of these as you feel necessary until you're comfortable with this, and then we're going to move on to looking at the converse of Pythagoras' theorem. Okay, the Pythagorean converse is basically, it's the same idea. It's still using Pythagoras' theorem, but it comes at it from a slightly different perspective. And what it states is that if you have a triangle, A, B, and C, and the legs are in the relationship a squared plus b squared equals c squared, where a and b are the two shorter sides and c is the longest side, what that means is it's a right triangle. So previously, the initial statement of Pythagoras' theorem was, with any right triangle, the sum of the squares on the two shorter sides equals the sum is equal to the square on the hypotenuse. In this case, it's the other way around. If we have a triangle where the sum of the squares of the two shorter sides equals the square of the longer side, that means that the triangle was a right angle. It was a right triangle. And also what it means is if they do not equal, if the relationship is not true, then the triangle is not a right triangle. So let's look at some examples of how this can be used. Okay, so we'll start off with a simple example. Is this a right triangle? We've got a triangle with sides of 5, 11 and 12. Is it a right triangle? So let's try this into Pythagoras' theorem. If it is a right triangle, then 5 squared plus 11 squared will equal 12 squared. Let's see if that's true. 25 plus 121 equals 144. Put these two together. 146 equals 144. This is clearly not true. So what we say is it's not a right triangle. Okay. Let's try with a different problem. Let's try with a triangle of sides 5, 12 and 13. Is that a right triangle? Well, what we have to do is we have to do exactly the same thing as before. We have to, best thing to do is to sketch our triangle and put in the sides in the appropriate places. I think we'll look first of all for the largest number, and that is the one which is potentially our hypotenuse, and then the other two values can go wherever you want to put them. You need to put the largest value where you think the hypotenuse, or where the hypotenuse should be, and again, we'll try our theorem to see if this is true. 5 squared plus 12 squared equals 13 squared. Is that true? Again, 25 plus 144 equals 169. 25 plus 144, add them together, 169 equals 169. Excellent. That is true. So this example, it is a right triangle. Okay? Right, so the problems we're going to be working through there. On the next page, and questions 36 through 44, which I'm going to include here. And there they are. Okay, that's pretty much it for this unit. There are quite a few word problems a little bit further up that same page, which you could try. So I would suggest questions 31 and 32. Then 33, 34, and 35. Okay, I'm just going to include all of these problems at the end of this video. You can work through them, check the answers, or talk about them with me in class. there's questions 31 and 32. 33, 34, and 35. Great. Okay, that's it for today. Complete this and then do the homework, then move on to the next topic.